Good afternoon, everyone. Thanks for coming. Really pleased to see such a good turnout, and we've got a really good turnout of people online as well, so it's fantastic. Firstly, we'd like to acknowledge this land that we meet on today, which is the traditional land for the Groundwater people, and we pay respect to elders past, present and emerging. I'll start. Many of you won't have heard of PIANC. We're aware of that, and we're trying to do something about that today. PIANC is, we've got a very mobile and active Australia-New Zealand chapter, which is broken down into regions, and here we are trying to promote things in South Australia today. So PIANC is the World Association for Waterborne Transport Infrastructure, which is a mouthful in itself and doesn't really go that well with the acronym. Bear with me. It started off as the Permanent International Association of Navigation Congresses, which was actually far better described as, it was formed at the start of the formation of the Suez Canal. It was basically a conference to try and get the best and brightest people from around the world together to try and do something which was a truly world-changing piece of infrastructure. So successful, in fact, that it was decided to keep that moving. Headquartered in Brussels, national sections in 6 continents, and again, Australia actually punches well above its weight as a national chapter, and certainly has the largest number of corporate members out of any chapter in the world. It is broken into several commissions, which probably don't read it either, they should, but MARCOM relates to all things maritime, there's recreational navigation, there's an environmental stream, a young professionals group, which in PIANC language is 40 or under. So yeah, don't worry if you've got some grey hairs coming up too early. And then not so relevant in Australia, but Inland Commission, which relates to inland navigation, which is certainly large still in Europe, Asia and North America. Regional chapters, this a bit outdated, this slide. We have decided to separate Northern Territory from Queensland and certainly Tasmania from Victoria. So we now have active chapters in each state and territory in Australia other than ACT, and New Zealand also, we have a chapter over there. So certainly covers Australia and New Zealand, and there's been a lot of work gone into the regional chapters and development of regional chapters within PIANC over the last 5 years. Just rolled out a new strategic plan. I'm here as the new chair of PIANC, taking over from Will Glaymore, who had a very, very strong approach to taking PIANC forward from the likes of Ron and Neil Lawson also, who were, I guess, the founding fathers of PIANC in Australia. But more than just, I mean, PIANC's known for its technical documents, technical information. It can be thought of almost as an international standard when it comes to a lot of things we do, for things ranging from fenders design to design of navigational channels, things relating to dredging. It's a fairly broad church. But beyond that, under Will's vision, and certainly something I intend to continue, we wanted to make about leadership within our industry, attracting people to the industry in the first place, and certainly something that I've got a personal interest in is really reinforcing PIANC as a community. We have a very advantageous position. If you go to a Coast and Ports conference or a PIANC APAC conference, you find a very collegiate and collaborative group who are, you have people with theoretically enemies or certainly competitors who collaborate on a weekly basis. It's very unique compared to a lot of the other engineering things that we work in. So with that, I'll hand over to Paul from Flinders Ports. Paul's going to introduce Ron and give a quick little summary about PIANC in South Australia.
Thanks, Luke. So first of all, thanks all for attending. We have, hopefully everyone finds their way in here. It's a bit of a maze to get in, but we have 71 people registered to be here in person and 223 online. So thanks everyone. A special thanks to Ron for coming over, and a group of people that helped put this together. Annabelle, Luke, Dish, Cyan, Amanda, a huge big thank you to Heidi at the back, and Eden and Corey from Community Cafe, who are helping out right at the front. We'll also like to thank our sponsors, WGA and Flinders Ports. PIANC in South Australia is relatively new. I put my hand up to get involved in 2018. Since then, we've done a couple of events, about one a year with the COVID interruption. So we've had a social network in 2018. We had what was probably to date the most successful venture, the dredging tour, when we were doing the outer harbour dredging in 2019. We did a Port River tour in collaboration with the Australasian Corrosion Association in 2020. We took a year off for COVID in 21, and we're back again this year with this presentation by Ron. The goal really is to build the network of people that are working in this industry around this sort of infrastructure, so that we all know who's in the game. We can pick up the phone, call, have a chat, find out how they solve their problems and learn from them. So just quickly, we'll have Ron join us in a moment. We aim to wrap up that by about 15:15 and have some time for questions by about wrap that up about 4:30, at which time we'll have some food and drinks at the back so everyone can have a chat, and please do stick around. We'll close up and all go home about 5:30. Oh, sorry, I'll go back. So just to introduce Ron. Ron, Honorary Associate Professor Ron Cox has had extensive experience in coastal, ocean and port engineering, coastal management, water supply and wastewater, groundwater, climate impacts and environmental impact risk assessments in these areas. Working both within Australia and overseas with industry and government, including local, state and federal. In 2008, Ron was awarded Engineering Australia's prestigious Sir John Holland Award for Civil Engineer of the Year, in recognition of his long-standing and continuing contribution to the profession and community, particularly in the field of coastal engineering. From 2009 to 2020, Ron led the Australian Climate Change Adaptation Research Network for Settlements and Infrastructure. There's an acronym with that, but I'll needn't go there. With a focus on coastal settlements, built environment, infrastructure, urban planning and management. In recent years, Ron has provided advice on coastal policy reform to Commonwealth and state governments. Since 2013, he has been particularly involved in the coastal policy reforms within New South Wales, and throughout 2015 and 2016 was actively involved in the drafting of the new New South Wales Coastal Management Act and its supporting manual. Ron was a founding member of the Independent New South Wales Coastal Council in 2018 and served for 2 years until 2020. And we're very lucky to have Ron with us as part of PIANC. With that, I'll hand over to Ron.
Well, thank you for that, Paul. I hope I can live up to all those nice things said about me. I think excuse me, it's not COVID, it's just a cold. I think the slide says it more relevant to this group is my involvement with PIANC, where I'm a member of various international commissions with PIANC, COCOM and ENVICOM, and also a member of the Permanent Task Group on Climate Change. And I'm a founding board member of PIANC Australia and New Zealand. Okay, a little bit of history. Some people will remember this, most won't. The National Committee on Coastal and Ocean Engineering was groundbreaking within engineers and practicing coastal and port engineers in Australia. Back in 1980, we recognised the importance of climate change. And in 1991, we produced a volume which was a guideline document for looking at a guide for coastal and a related port engineers is relevant as well, to work how to deal with climate change in coastal and ocean engineering. Okay. Subsequently, the initial volume's been upgraded 2 or 3 times, and we've got new volumes which were supported by the Commonwealth Department of Climate Change when it existed. So, if you like, climate change is not something new to engineers working in Australia. The documents, some of the covers change in time, but these are reasonable ones. They If you haven't read them, I encourage you, if you're interested in climate change and as an engineer, how to deal with it, or even as a manager in volume 3, how to deal with managing climate change in coastal issues, you should read them and get hold of them. Okay, the first volume, back in 91, we had several workshops. We identified the key climate variables. We actually identified 75 type related activities where climate change would have an impact and you needed to consider it. We developed decision trees for how to manage and to assess the impacts. A lot of work, excuse me, on the probability of exposure, design life expectations, and picking design events. We produced in that document a series of checklist boxes and case studies so people could actually have something to work with. Now, if you look at that, just remember that, because nearly every subsequent document that's been produced since by NCARF, ACANSI or PIANC almost follows the same format. And it's not surprising because they all picked up this volume 1 as a good reference document to start from. So if you like, we've got a lot of credibility in the game. People who come to my lectures will probably remember this. How many people in the room actually have to go to community and discuss design events? Why in New South Wales, Queensland, in the last 6 months, we've had 3 floods that went above all the expectations. And it all comes back to this misunderstanding of design probability, selection of design event, and your exposure risk. Now, first of all, we've got this nightmare of terminology. The 1 in 100-year event is the 1 in 100-year average recurrence interval, which is the 1% AEP. And as engineers and technicians, we prefer to use the 1% AEP, annual exceeds probability, because in technical terms, it explains better what it is. The community, if you go to a meeting and try to explain to them, most of them glaze over, right? If you're spending, and the anecdote I've summarised here for people to try and get to grips with the community and to understand why they don't get it, is anybody in South Australia, in Sydney, you're spending $2 million to buy a house. Here, maybe $1 million, but you're going to the bank to take a big mortgage out for the rest of your, at least 30 years of your life. And you're looking at this wonderful property on a riverbank or in a floodplain. And you want to know what's the risk that you're going to get flooded or exposed in a reasonable time, say 10 years. And you say to people, what sort of risk are you prepared to take that in the next 10 years, that property you've invested in will actually suffer an extreme event? And you say to them, would you expect or accept a 10% chance? No way. A 10% chance that I've invested $1 million or more and I'm going to get at the extreme event. That's what we give them at the moment. Because generally across most of Australia, in terms of floodplain and coastal development, we adopt the 1 in 100-year ARI as the design event. If you're clever, you can convince them that maybe they should expect it's reasonable perhaps a 1% chance. Initially, they'll all say no chance at all. If I'm buying it in the next 10 years, I don't want to ever be flooded. You convince them that maybe a 1% chance, then we as engineers or managers should be designing for the 1 in 1,000-year ARI event. And if you did that for Western Sydney, you wouldn't have any more houses. So we've got this real conflict between what the community's expectations are in terms of risk exposure and what we regularly do in terms of picking the design events. And it pervades everything from port development, floodplain development, and coastal management. Let alone the thing on the bottom. That's just to deal with the current climate. Then you add in climate change and the expectations we're going to have more intense events. And we're really in a problem area where we are running out of land that is safe for development. So this is a big issue for us into the future. What's happened over the time? What sort of guideline documents we have in terms of how we should behave? We've got a code of ethics. And the only thing that I would remind people in the code of ethics, your responsibility as a professional engineer is to the community first, not to your government department, not to your consulting boss. Your responsibility primarily under the code of ethics, like doctors and lawyers, is to the broader community. That creates all sorts of conflicts as well. Okay. November 2014, Engineers Australia brought out its sustainability policy, it brought out its climate policy. And the climate policy is essentially based on what NCCOE did in 1991. But it took the headquarters, you know, a catch-up period of time to catch up. And they finally did it. And again, but Engineers Australia is very broad. It's got structural engineers, it's got railroad, it's got all sorts of people. Most of them who didn't want to be concerned about climate change, but they were dragged into it by community pressure. PIANC, again, we'll get to it. PIANC actually got involved in the climate change issues back in about early 2000s. But again, PIANC headquarters, a little bit slow, big bureaucracy, lots of people to keep happy, worried with lawyers reading every word in the policy document. It released its climate policy in 2019 before COP25. Here's the meeting of all the nations of the world on climate change. Both are similar. First of all, the organisation recognises that climate change is real and it's caused by our man-made intervention. Secondly is our organisations need to have every member of it cognizant of that and work to allay the problems that come from climate change, to work with it and consider it and work around it. PIANC originally got involved in climate change back in 2000. It produced, and again, when you see all these working group reports that I talk about from PIANC, you think, oh, you get a group of people together and they do it in a year. No. Get a group of international people who only get to meet once or twice a year. It takes at least 3 years to get a working group report completed. Sometimes they take 8, this one. Right? Whole heap of people with a whole heap of vested interests, all pushing, you know, Germans, French, Americans, Australians, all pushing to get their bit into the document. Okay, so TG3 was the task group that was formed within Environmental Commission to come up with a climate change document for the PIANC sector. Kathleen White from the US Army Corps of Engineers led that and chaired the group, herding the cats, keeping them all together, and produced the document, which is then used by, and it's relevant to all the other working group reports. So it had to be written in a way that all the other commissions and all the other working group reports could use it as a reference document. You'll notice climate drivers, guess what? They're in essence all the same ones that occurred as the climate parameters that matter in the NCCOE Volume 1 of 1991. Temperature, rainfall, water levels, wind, waves, all the obvious climate parameters. But the ones that are different to what we deal with in Australia, is essentially the difference is they have a lot more worry about ice, because it's an international group, so it actually worries about navigation up in the northern parts of the world. Ice and icing conditions were a concern. they also were worried more about inland navigation, inland issues, whereas we don't in Australia. It included adaptation and mitigation responses and looked at greenhouse gas emissions and what you might need to do to control them, i.e. alternative fuels. Back in 2008, it was already identified as an issue for the future. Now, when people download this, this figure is distorted in all sorts of ways. Just read it in terms of the trends that it indicates to you. So that if we were able to cut greenhouse gas emissions and bring them back down to virtually nothing from where they are now, get down to net zero, but even if we take 100 years to do it, notice that the CO2 in the atmosphere will still take 100 to 300 years to stabilise. Temperature stabilisation will still take a few centuries. Sea level rise will take many centuries to a millennia to stabilise. And that's in the good case where we all pull together around the world and knock CO2 and carbon emissions down in the next 50 years. We're still going to be dealing with sea level rise, rising temperatures for a long time to come. That's a big message. Now, the graph is heavily distorted. Don't assume the relative values. Why does it matter? For all the people in the ports area, you know that all ports are around the coast. Guess what? They're subject to problems with sea level rise straight away, subject to problems with extreme weather and waves and winds. So the major ports of the world are already identified as having issues that will get worse with climate change. There are other figures for the world which shows the population of the world, which is also heavily centred and focused around the coastal perimeters. So all the issues that we have with ports, with climate change, are really important for the populations of the world that are all in those low-lying coastal plains. Mitigation is part of TG3 and is now increasingly getting more emphasis from PIANC and regulators. But to put it in perspective, the culprits are these guys, trucks and cars, in terms of the transport sector. But when we listen to our politicians, all we ever hear about is energy. Right? Now, energy is a much higher contributor to the greenhouse gases, so it's the one that gets most focus. But eventually we're going to have to turn around and get back to the transport sector, which is about 20% of the world's greenhouse gas emissions. And the big contributors are cars, trucks, and the transport sector, whereas the shipping is way down here. So you could argue from the port's perspective, a little bit like some of our politicians, that even if Australia does everything, we're only 1.3% of all world emissions, so it won't matter. So we can sort of relax and not do it. I've had discussions with Paul and New South Wales ports. The big issue is your licence to operate. You need to be a good corporate citizen. If you lose the confidence of the community that you're not pulling your weight, life becomes difficult for you. So there's an inherent social reason why the port sector is moving much more quickly into the greenhouse gas carbon abatement space. Okay, what's happened since TG3 in 2008? It was based on AR4, the IPCC assessment report number 4. Since then, we've had the 5th assessment report. We've had a special report on global warming of 1.5 degrees, which warned us that if we didn't keep emissions to a level that would not increase temperatures by 1.5 degrees, it would be catastrophic. Catastrophic for the environment, catastrophic for populations, and catastrophic for ecosystems. So that was the big wake up. Then we had the special report on the cryosphere and oceans, which looked specifically at what happens in the watery side of the world and ice. And then finally, we've got the 6th assessment report, which came out just last year. Okay. I'll very quickly go through AR5, updated AR4, similar global climate models, bigger ones, better ones, more processes included, and it introduced this thing. Instead of AR4 had emission scenarios, suddenly AR5 comes out and there's all this concentration on representative concentration pathways, RCPs, as a way of identifying what is a scenario that we might go down to reduce carbon. And an RCP, the bottom one shows you, the RCP 8.5 is a pathway that in 2100 reduces our emissions, the radiative forcing, to a level of 8.5 watts per square metre. And if you're anyone other than a keen climate scientist, this is gobbledygook. Why such concentration? Why did you make it so complicated? Because if you're a scientist and a climate scientist, that makes you even more important, because no one else can understand you. But imagine going to the community with this rubbish, right? So anyway, that's one of the big problems with IPCC. Lots of egos, lots of people wanting to make themselves important. They do great work, but then they lose it in terms of the way it's presented and making it too complicated. But what does it show? Here we go. This is the temperature, global average temperature. So this is what's happened up to 2005. And this is the projections from all the climate models for RCP 8.5, which is business as usual. From 2005, we just don't do anything different. And the temperature will get up to, 3 to 5 degrees higher than what it is in 2005, which is catastrophic in terms of ecosystems and our life. And Europe's struggling. I mean, we've all seen it in the recent months. Europe's struggling with 40 degrees C. Can you imagine the UK with 40 degrees C? They can't cope with 30 degrees C, let alone a few days of 40. So it's quite catastrophic. And if you were able, with RCP 2.6, you can actually stabilise it. But that's a lot of effort. That's a really tough call to do that. Sea level rise, and you'll see RCP 2.6, sea level rise about 0.4 of a metre. And if we do nothing, keep going as normal, it gets up to about 0.8 of a metre. And that's surprising. You go, okay, this is AR5. What did we predict in 1991? Guess what? 0.8 of a metre by 2100. That's what we said would happen if we didn't do anything. So nothing has really got dramatically different in terms of 2100, what we think will happen. I love this. 2 slides. IPCC, shoot yourself in the foot. They spent a whole chapter explaining the confidence terminology. And the whole report is all written in, we have high confidence, medium confidence, low confidence on every predicted projection. And all it means is high confidence has about an 8 in 10 chance of occurring. Low confidence is about 2 out of 10. 2 out of 10 low confidence means we don't know. Essentially, we have no idea what's going to happen. You're telling everyone this is what's going to happen, and at the same time you tell them you don't really know. Gets worse with likelihood terminology. Have a look at the categories. How many have we got? From virtually certain all the way down to exceptionally unlikely. Why the hell? And when you read the report, they use these terms interchangeably all the way through it. And we as engineers and scientists would say, why didn't you just use the probability? Would have been much simpler. And there was a whole group of IPCC people who said, oh no, we're writing for the community. If we gave them probability, they wouldn't read it, but they understand words. And then they came up with all these different categories of words. And you wonder why, if you want to set up a scenario where the skeptics of climate change have got a lot of ammunition, it's all in the reports. Okay? So as much as they do fantastic work, again, I believe they shoot themselves in the foot in the presentation. I like this graph, right? Because what it shows is, and there's no scale on it, it's just looking at the complexity of the processes against the uncertainty of the projections. And we'll only look at the top one. So as you go from temperature projections from climate models through sea level rise, through wind, through waves, through sediment transport, water quality and ecosystem function, every one of those to build into the models is more complex. And every time you build extra complexity in, the uncertainty increases. So when we're using climate models to project on what's going to happen in ecosystem functions, we get an answer, but it could be in this room or the next room. It's not clear. We get an answer, but we've got a broad range of possibilities around it. Regional differences are important. So on this graph, this is just showing annual mean surface. So these are the RCPs 2.6, and you're going 2050, 2100, 2200. So we're stepping outside of this 2100 range. And so if we are able on temperature to keep the emission scenarios to 2.6, you'll see that temperatures increase, but once we go beyond 100 years, we can actually see the temperatures falling. So if we can do something, we can have an effect. But certainly when we get to 4.5, 6 or 8.5, it just gets terrible. So if doing nothing, it's bad enough at 2100, but by the time we get to 2200, we're looking at temperature changes of about 8 degrees. Whoa. People start to die at about 3 degrees. So we've got a real problem with why we need to change. For the coastal and port engineers, wave heights are important. A lot of work, and this was mostly led by HEMA from CSIRO, who did most of the work in 2013 to 2017. And everyone sort of says to him, well, you've got a whole team. Yeah, the team of one. He did most of this work himself, but CSIRO takes a lot of credit for it. Now, again, we've got longitude. The first map up on the top left here gives you the distribution of wave heights around the world at the moment, or in around about 2000, or in a broad band of between 80 and 2010, right? Then we go to what is the change we expect in 2100, roughly, or 2090, around the world with percentage changes. And you'll notice that in most parts on the annual basis of the world, the wave heights go down other than in the Southern Ocean. But that's the annual average. But down here, we can actually see that the annual is dominated by the January, February, March period of the year, which looks exactly like the annual. But the July, August, September seasonal effects, you actually have significant increase in wave heights across the Pacific. So what you need to realise is these global average changes that you get out of IPCC projections that people tend to latch onto, there are regional differences and there are seasonal differences. IPCC SROC report in detail, lots of information. This is the figure 1, and there's about 150 figures. They are all complex, they all present a lot of material. It gives you clear indications of why sea level rise is occurring, The modelling is quite explicit. It gets into changes in mean surface, so it differentiates air temperatures from sea surface temperatures, but you see the same trend. The 8.5 is increasing, whereas if we can satisfy on RCP 2.6, we can stabilise temperature. We look at ocean heat content converted into sea level rise. We can look at the ice sheets and the contributions, and they're not that significant up to 2100. The Greenland ice sheet, 0.1 of a metre contribution to sea level rise. The Antarctic ice sheet about 0.1 as well, and that's at the 8.5 scenario. And the glacier losses are higher. For the first time, the models also incorporate indications of changes in acidity levels and oxygen content of the oceans. And for ecosystems, these are the important parameters. Even that subtle change in pH that might occur would be kind of catastrophic, and the change in oxygen will be pretty catastrophic, as well as heat for barrier reef systems. For those of you who like to get information out of reports, I can recommend the SROC report for what you want. It actually also does analysis for extreme water levels for all these sites around the world. So it actually gives you extreme water levels with climate change, tide surge, and comes up with, and if you wanted to test it, for Sydney, we've got the historical data in terms of return period, and then we've got the sea level rises added to it for scenarios. AR6. GC, in summary, even since AR4, the GCCMs are getting better. There's more of them that are accepted by the community as being reasonable, so they get added into what they call an ensemble. What they do is they run 30 or 40 of these models, get the results, and then average them all, or do a probability analysis on the results of all the different models. And that's what goes into the global projections. The changes, even going back to AR4, are not great. So all the people, the old people in the room who work with AR4, there's nothing dramatic changed, just a lot more nuance, a lot more data on regional and seasonal behaviour. The important point is this one. Even if we control the emissions, things are going to keep going. It's like bringing the big tanker into port. It's already got its momentum up, and no matter how hard you try to pull it around, it's going to keep going, and you can only deflect it slightly. Uncertainty. I talked about uncertainty, and IPCC people, after AR5 came out, they were scientific papers everywhere talking about the uncertainty in the projections. And I can tell you that if you walk into a room of a community people and you start to tell them we've got all these projections, and then you try to lecture them or tell them about the uncertainty in all the projections, the answer is, so you don't know. You've given us all these wonderful graphs, and then you tell us how uncertain you are. So why bother? Why convince us we need to do anything? So a social scientist who worked on the NCAF projects, who came from South Australia here, she actually put and told the community of NCAF and all the adaptation climate science people that you should never use the word uncertainty. Cross it off your list, get it out of your literary head. You don't talk to people who are not part of your peer group about uncertainty, because you'll lose them. You can't believe it. AR4 scenarios, AR5, RCPs, SROC, 1.5 degree report. Everything ever since has been RCPs. What did they do in AR6? No, RCPs are out. We're now looking at shared socio-economic pathways. SSPs are in, RCPs are out. Duh. shoot yourself again. But then they spent about a lot of time explaining that SSPs are really just RCPs, but in a band. So SSP 1 to 1.9 is essentially radiative forcing between 1 and 1.9. And that goes up in 5 bands. RCP AR5 had 4 RCPs. Now AR6, sorry, has got 5 bands, just to make it more complicated again. So, another but, AR6 has fantastic graphics. So the terminology gets complicated, but the graphics and the presentation material is really good. So one of the things they do is they say, we're not even going to talk about SSPs when we tell you what's going to happen with global warming. What we do is we say, these are the changes in annual temperatures you would get if we are on a pathway that ends up at 2100 with 1.5 degree change. So this makes it easy to explain to the community that if we were on a pathway that ended up with 2 degrees, this is how it would be distributed around the world. If we're on a pathway to 4 degrees, this is how it would be distributed around the world. And you'll see that most of the temperature changes are concentrated again up in the northern latitudes. Precipitation, so if you like, the temperature stuff is pretty straightforward. If you see the trends, all the red stuff, most of it occurs up in the northern part, but gradually if we get up to high temperature changes, a scenario where we don't do enough, we start to see changes down in the southern parts, and that'll affect, if you like, the Antarctic ice belts. Precipitation looks okay. This is after 1.5, but suddenly, as you get more increase in temperature change by 2100, the precipitation distribution is much more variable across the planet. There's parts that get a lot wetter, there's parts that get a lot drier, and they tend to be in different belts. Skip through those, we've done that. So update. We've been working on the update to the TG3 2008 report for about 3 years. Each time we thought we had it finished, there was a new IPCC report, and we made an agreement within the committee that we would only produce it when we actually had the latest IPCC results. We were going to target AR5, and then they brought out the SROC report. We now upgraded. AR6 came out last year. We expect this report to come out now later this year. It has some wonderful graphics in it as well. We've got the advantage of we've got all the IPCC reports. This is a nice graphic, and what it shows is the main climate variables here: temperature, water level, sea level, precipitation, waves, wind, the impacts in another row across here. What do these things cause for different assets and operations within the port sector? And guess what? That's put into a graphical form all the checklists we had in the original National Committee Volume 1 in 1991. And guess what they did? They got a graphics person to take that original NCCOE report and turn it into a nice picture, because all those things were previously identified. Checklists. UNCTAD, United Nations task group on the transport sector, actually did a survey in 2017 to look at which climate variables had most impact on a port's infrastructure and its operations. Very useful document. And what it did, I think there was about 43 ports responded and went into the survey. And it clearly showed that precipitation and winds were the dominant parameters affecting ports operations. Recent PIANC reports that have come out, Climate Change Adaptation Report 178 and the ENVICOM Carbon Management for Port, I draw your attention to both those. There's the 4. There's a lot more across MARCOM and INCOM, but these are mostly ENVICOM and the Permanent Task Group on Climate Change. Jan Brook led the group doing Report 178 that had Australian members on it. And Jan is quite passionate about the need to respond. She's a consultant. She's been very active in PIANC, but she does work for a lot of the port sector. And her main emphasis has been we either don't bother or we actually think about our future generations. And that drives her personally to be involved in producing things on adaptation. It's very simple. It's like a lot of these processes. It's got lots of checklists. It's got a procedure. You can actually work your way through decision trees to look at assessing the risks, looking at the vulnerabilities, and then looking at adaptation and resilience measures you might find at work. The carbon management, again, you see everyone who does anything in climate change or any management always has a nice little circular diagram where you step through the process, end up back at the start and reassess and start again. So it's nothing new in all of this. So that was done by Doug Doherty from Rambol, a consultant, again, working on an international group for PIANC as the lead. And it actually is quite, if you haven't read it and you're looking at within your port or your business, looking at carbon management and reduction, it's fantastic. It looks at the carbon framework. It's got way you quantify and measure carbon and also monitor your effectiveness in reducing your carbon footprint. And it also has a lot on financial considerations, how you might actually, what it might cost you and what you're losing by not doing anything. It also includes, and you'll see here, 5 major case studies, which gives you an idea of how other ports have approached the problem. And you've got all their working documents there in the case studies. NCARF, when I was running Akanzi, it is, the Australian club, anyway, we won't go there, it was a nightmare. But within NCARF was a major breakthrough in adaptation for climate change. It was funded from 2008 through to 2017. It produced a whole library of useful reports. The danger is that they're presently sitting as a library resource run by Griffith University for a short period of time. So I would encourage any of you to go to NCARF website, and if you like, get one of your IT people, do a dump in case they all get lost. We specifically got a project up that RMIT did, looking specifically at ports, understanding the climate risks, looking at the resilience of ports, and they went through those reports, they went through case studies, looking at defining the risk, defining the vulnerabilities and what might be suitable options. And they used Gladstone, Port Kembla and Port Botany as the 3 case studies. Excellent group of reports. Again, lots of ideas to actually help you with. The game changer, and I'm going to finish on this one, I won't go the others. What really changed, we were fighting to get adaptation and climate change into the mainstream of politics. And again, 2016, 2017, along came BlackRock. You'll hear their name occasionally. The biggest investment company in the world. They manage trillions of dollars for shareholders and investment bankers. They came along and said, shareholders and companies need to, or shareholders need to be aware that boards and management decisions in your company fully consider climate change or else they're negligent. And virtually within a year, it was picked up because they're the big boys. Lots of other companies jumped on the bandwagon, CEOs, board members, to the point where now it's almost accepted. And there is various documents around the world where board members and companies have to fill in the documentation that gets filed with regulators to show that they have considered climate change in any major investment decision, or else, this was the key, the directors could be personally liable. Whoa! You're a director of a company and you're going to be personally liable with a regulator like APRA. You start to listen and you start to react. And now there are trillions of dollars in investments. And that's also why you find banks won't lend money for what they see as a likely stranded asset investment like a new coal mine, because they're frightened of these particular regulations. Okay, just a quick one. How many of you have heard of the investment group on climate change? Couple of nods. All the rest of you, write down IGCC. Get onto their newsletter. They send them out every week. They produce a whole range of reports that tells you what's happening in this world of investment for climate change. It's free. They run workshops, they run conferences. It's terrific. But all it is you can just keep up to date with what the big end of town is doing in respect to climate change and investment. What if, just finishing up, scenario analysis is important. Whenever you think you've got the right design, you've gone through it, you've said we're still going to use the 100-year one, ask yourself the question, what if it's wrong? What if we get the 200-year or the 500-year? What's going to happen? It's very easy. You don't want to be like this guy, walking home with his shopping, a flood in Georges River, Western Sydney. The water starts to flow. If you look as engineers, you look on the downstream side of the bus shelter, that water's flowing fast enough that if he stepped off, he would be washed away. If the water keeps rising, he's in deep trouble. So that's, if you like, that's the uncertainty. It's also a question about the what ifs we need to ask ourselves and protect people like him. Thank you.
Thank you very much, Ron. That was excellent. We'd like to put out to the crowd now, time for questions. So if you could raise your hand, I'll point to you, ask a question. I'll repeat that for the online audience and then give Ron the opportunity to respond. So any questions? Yes.
Yeah, so thank you very much. It was a great presentation. I really pick up and agree with your point about the language and accessibility of information, how it's being provided. My question then is there any really accessible go-to source of the MUG's guide to impact of climate change and the causes that is trustworthy, doesn't understate it, and doesn't overstate it?
Okay, so just to repeat that, is there any really accessible guide to climate change with causes and just impacts?
It doesn't overstate or understate.
Okay, that doesn't overstate or understate.
The Dummy's Guide to Climate Change. I think there's some good documents. You won't get the Dummy's Guide out of any of the IPCC reports, even if you like, the summary for policymakers. It's still complicated. I think some of the better works that I've seen that explain it and the need for adaptation, which could be updated are probably some of the social climate impact works that were done under the NCAF banner. I can't remember any of them by now, but by name, but if you like, I can look it up for you and maybe give you some indication. But I think there's some very good. It wasn't done by it was done more by the social scientists looking at the implications of climate change and how to talk to the community about climate change and how to adapt. It was written in that context.
Yes.
Thanks, Ron. The question, the image you showed with the UNCTAD graph showing that wind is likely to be one of the major impacts for generally. Do you think that holds up for in the Australian context? Is that what we're likely to see for Australian ports? Do you have any thoughts on the biggest, I guess, impacts for Australian ports?
So just to repeat that from Joel, you pointed out that there was a graph there with wind as one of the highest impact issues with climate change, and you want to know if that holds true with the Australian infrastructure and environment.
Again, if you go to the document, most of these ports were in Europe, a few in Africa. And again, if you look at the distribution here, the 11 out of these are the numbers of ports that responded, and of course you got multiple. So 11 ports responded that wind was a major issue for their infrastructure, but the biggest one is 27 for ship operations. So it was regarding berthing and safe operations of the vessel in the harbour and in the port with strong winds. When NCAF through RMIT did its study for Gladstone, Port Kembla and Port Botany, wind was not the issue. The major issue for them was storminess and precipitation. And particularly for Port Botany, the storminess was affecting the storminess was mainly affecting the ship arrivals, and it could have been storms in the Pacific or storms elsewhere that was hindering the ships sticking to their schedule. The precipitation was in regard to the hinterland connections, flooding of the land side. And we have that in every port all around the world. And in recent times, you've seen it in Europe, where they've had their big floods and a lot of their port operations have been impacted because of the precipitation events. And it's not the port itself, it's the hinterland connections that have been interrupted.
I'll go over to Annabelle first. And Luke, I'll let you have the last question. So the question is there any worked examples of dealing with managed retreat? Oh, can you speak to that?
In regard to ports. I think no, ports have this major problem with the license. We've talked about it, is the license to operate, and they're a little bit like airports. You build the port, then people come and build houses around it and complain that you're a nuisance. So essentially managed retreat, I'm assuming you're in regard to coastal development, coastal housing, coastal infrastructure. I go back to several papers that were written back in the mid-2013 to 2017. There were international groups looked at the impact of climate change, and they looked at it countrywide. They looked at Argentina, they looked at Malaysia, they looked at a whole range of countries, the impact of climate change would have on those communities, and it was all to do with coastal. And the lesson that came out of that was, at the time, certain countries could adapt quite well, and they were the countries that were rich. because they could afford to protect. The only option, and once the GDP or the value of property and infrastructure on the coast got above a certain level within a country, retreat was not an option anymore, both financially and socially. And that's, you know, there was a series of about 5 reports looked at different countries, and I can remember there was a summary report that virtually, in simple terms, said those things. So if you were in a country that had fishermen's shacks on the beach, it was quite easy to retreat. But if you're in a country where the infrastructure on the coast was an oil refinery or a port or something, then essentially retreat was not an option anymore. And it was also mainly an option because it was financially uneconomic to do it, but also you couldn't move it anywhere else. You actually had encroachment behind that you couldn't move into. I can brain at the moment, can't think of the reference number, but I can probably, while we have a drink, I'll remember it.
All right, time for one last question, Luke, and then, okay. And then we will be around for the next hour, have a drink and run some questions.
It is a question, but I've got a long-winded intro for you, Ron. So I've seen you do a similar chat about, I don't know, 4 or 5 times now, and thinking about 5 years ago, you did a talk to a PIANC AGM where you spent a fair bit of time looking back, not just sort of looking forward with modelling, but actually going back through a lot of the data, which is, you know, you can't argue with. And if I go back to perhaps that first question and imagine that you're not talking to a room full of engineers or scientists, but you're at a dinner party talking to someone who's got strong views and you're trying to actually prove them wrong. If you were to refer back to, without the assistance of your graphs, but when you need to point at something which is the firmest indicator of that we have a problem now because of what's happened in the last 20 or 30 years, not because of what modelling predicts going forward, what do you point towards? What's the most compelling thing that you use as a reference?
Before the last year, it's quite easy now. I think we've all, it doesn't matter where you are in the world, in the last 3 years, we've seen major bushfires all around the world. We've had heat waves all around the world, and we're also seeing more extreme flooding and rainfall events. So these days, it's quite easy to say all that means the climate has changed, and the reason why it's changed is because the evidence is the climate has changed, and it's changed dramatically. And even in all the projections, this is probably one thing where IPCC understated the implications. They did not foresee the dramatic impact on worldwide communities happening so quickly. They did foresee bushfires and more heat and whatever, but they didn't see it happening as fast as it has, right? So those things are easy now. Prior to that, you'd have to look at people with sea level rise. All they need to look at within an estuary or on a coast, look at the trees or the vegetation that's falling into the water. That means sea level rise is happening, and it's not normal, right? So that was one of the key indicators I used to use with people on the coast. Look at the vegetation, look at the trees and the mangroves that are actually falling over on the water edge. Equally, I guess, we virtually also have the barrier reef with all the bleaching events. And if you want to get to people's hearts in Australia, the barrier reef is the largest living organism in the planet, and we're not managing it properly. And it's being impacted by climate change and increasing temperatures. And one of the surprising graphs is that increase in water temperature is not that far behind. It's only about half the projected increase in air temperatures by 2100. So if we don't control the global temperature difference everywhere, sea level is going to increase, and that'll be very bad for our marine organisms.
Well, thanks very much, Ron. And everyone for attending. Please join us at the back. We've got some food there and some drinks. And I'll say goodbye to everyone online with that, unless Luke, you want to say something?
I'll let Ron do it. Ron, maybe we should have just a quick mention of PIANC APAC. I meant to say this initially.
Sorry. Okay, for those of you who are interested, PIANC has for a long time been involved in conference series. We powered up with National Committee on running the Coast and Ports Conference Series on a 2-yearly basis, and that still runs, and the next one is going to be running next year. The National Committee had a meeting on Tuesday. At the moment, it looks like it's scheduled to be held on the Sunshine Coast in September 2023. Now, because Coast and Ports was delayed because of COVID into so it was only held this year in New Zealand. It's a tight time frame, but it has to be held in the odd years so it doesn't compete with ICCE and other events. That ICCE is the International Conference on Coastal Engineering. So PIANC's been involved with Coast and Ports Conference, that's why it's called Coast and Ports, for many years now. They used to be separate conferences. There used to be a coastal conference and there used to be a ports conference. We amalgamated the two because it was senseless. We were fighting each other because a lot of the people who attend both. So it was quite silly. 2 years ago, the board of PIANC ANZ, Australia, New Zealand, decided that we would hold a separate, just a ports conference for PIANC participants because the demand was there in the off years from Coast and Ports. And we held the first APAC, Australian Pacific, and whatever, Australian Ports and Communities Conference, and that was held in Fremantle in 2020. So on that basis, we're holding the next APAC conference in Melbourne in September. And again, it was difficult because of the turnaround. We couldn't start to promote it until after Coast and Ports had finished. So really, the APAC conference in September is running on a very tight time frame, but it will be a success. I'm finalising the program at the moment. We have about 75 abstracts, good abstracts, and the presenters will be there to present. We've got good sponsorship, and it'll be in 3 parallel sessions over 2 days in Melbourne. So if anyone hasn't got an abstract in, but still wants to have a look at the APAC, it's under, the website is PIANC APAC, all one word, 2022. Have a look at the program. It'll be up there by next week. There's a lot of good papers that you may benefit from attending. So with that, I'd encourage anyone who's interested to come along. Also, any of you who are interested, join the PIANC South Australia chapter. I think the membership fee is pretty cheap, isn't it, to be part of the chapter, but to be part of the chapter, you should be a PIANC member. And you can do that by becoming a corporate member or an individual. And you can talk to Luke or Paul or any of the other chapter people, or you can go to the PIANC ANZ website to look at the annual fees. Having been a member of Engineers Australia and PIANC, I know where I get better value for money. But I'm still a member of Engineers Australia.
All right, thanks everyone, and thank you, Ron.